much. Okay, then I'm starting recording. Yeah, so good afternoon. So as it was announced before, today we are going to work on a high level versus low level languages. Yeah, and so the first, we are going to cover quite a few topics today. It's going to be, most of them are going to be theoretical topics. Yes, so characteristics of Python as high-level language, low languages, their characteristics, advantages of high-level languages and low-level languages, comparing of them, and choosing the right language for correct for the right task. Yeah. So, and the first thing that we are going to cover today is going to be. So we are going to talk about Python as high-level programming language. Yeah, so this is the language that you are using for your projects, in your GCSE exam, etc. Yeah. So what we are going to go through today. So the first thing that we need to understand about Python, that it's like most of high-level languages, it is human readable syntax and structure language. Yes, so for example, when you want to define something, new variable, you can name variable whatever way you want to. You don't need to define anything extra. In case if you want to add some conditional statements, loops, you're writing everything down in a way pretty understandable for us, for human beings, right? Then the next thing, it abstracts complex machine level details. Yeah, so 2 sessions ago, we were talking about abstraction and decomposition. Yeah, so we figured it out we figured it out that abstraction means defining in simple ways. Yeah, and in high-level programming languages, we don't need to know all these tiny details about how data types are announced, what restrictions they have, etc. Next thing, it's automatic memory management. You can also see garbage memory collector, that special files that are defined when you run the project. Yeah, so in high-level languages, we don't care about this because all of this is done for us. Yeah, we are going to talk about memory management in a tiny bit when we go to low-level programming languages. Yeah, so again, it's portable. You know that we were using our Python in Replit, VS Code. You can use it in Windows, Linux, macOS, whatever you want to. You can easily transfer your .py file from one platform to another one, and easily run it. Yeah, yeah, it supports like different data structures. Yeah, starting from string values, lists, dictionaries, etc. Yeah, which are not really common in a simple or low-level programming languages. Then the process of developing some project using high-level languages is way faster. Yeah, first of the reasons because a lot of things are hidden by abstractions. Yeah, and we don't need to waste a lot of time to build some new function. There are a lot of built-in functions already. Yeah. Now let's have a look at low-level languages. Yeah. So again, it's written closely to machine language, which is very difficult for human beings to understand. Yeah. Sometimes it's even written in zeros and ones, on the ways to easily transfer to zeros and ones. It also allows us to have direct access to hardware. Yeah. So what does it mean? It means that we can access our memory, our other storage devices, yet to work with memory. Then it requires manual memory management. Yeah, so let's talk about what memory management is. So we know when we create some certain variable, when we write some certain code, we always need to store all of these symbols somewhere in memory. Yeah, so after we store it in memory, yeah, we have written code, we decided to execute it, compilation was successful, and it is stored somewhere in memory. And in low-level languages, we must make sure that we are going to delete all of the files that we created after ourselves, all of this memory cell that we've taken. We need to clear them, so we will be able to run next processes in those memory cells. Yeah, let me have a look if I can draw here. Let's assume that we have some memory here. So let's call it 0x, 0x1, and 0x2. Yeah. So, and let's say we created a variable a which is equal to 1. This is integer, and we decided to store it here. Then we decided variable b with value 2 that we are storing there, etc., etc., etc. Yeah. So in high-level programming languages, we don't care about clearing all of these cells. Yeah. So we can either leave it there or the IDE can do it for us. But in low-level programming languages, we need to manually get rid of all of these values that we stored in the memory. Usually non-portable. Yeah, you can't just transfer one file and to transfer entire code to entire project. Yeah, they're usually languages associated with assembly languages or C-based languages. Yeah, and they are usually require technical expertise. Yes, so you need to be really advanced and have deep knowledge or understanding how the languages work. And they're perfect for the projects where you need to make sure you are having very deep control over your hardware. Yes, so for example, in case if you think about home devices such as a microwave oven, yeah, a regular stove, your kettle, how do these things work? Yeah, so definitely they were written using some low-level languages, yeah, because you cannot run it using any UI, etc. Yeah, so in such cases we were using low-level programming languages to set up control over hardware. Yeah, so you define the clock, you define the time needed to heat up the kettle, to control the temperature of the water in the kettle, etc. Now let's think about advantages of both of the languages, of the approaches. Yes, so the first one, we're going to start with high-level languages. Obviously, as we mentioned before, it has very simple syntax and it's easy to learn and understand these languages. It's, again, very easy to make different changes, to experiment with your code, with your projects, with your applications, etc. Yeah, by adding new features. It supports abstraction, yeah, so you don't need to care much about managing complex machine details, etc. It supports cross-platform, yeah, so easy to transfer from one platform to another one. For example, when we are talking about such languages like Python, it has a lot of open source libraries and frameworks. It has communities that's supported by a lot of people that are posting it on different online portals where you can download those libraries from. And yeah, it has large community support. Yeah, so tutorials, libraries, debugging assistance, etc. Yeah, so for example, you know it from my personal GitHub where I have posted a lot of on Python. So this is just one example. Now, let's move to advantages of low-level languages. Yeah, again, it's very high performance. I really like this example. For example, to print out 1 billion numbers in Python would take about a couple of minutes. In such language like C or C++, it would take less than a second. And now we come to the point that it is memory efficient. Yes, so again, by the way we are managing memory, yes, so we can make sure that it's not taking too much memory resources. It also allows us to directly interact with different hardware, yeah, hardware components, and it can let us go to low abstraction, yeah, so we can not just hide basic principles behind something abstract, yeah, we can directly work with it. And in comparison to high-level languages, it can lead to decreasing the weight of the programs and the storage it takes on computer. And again, it's the best choice for real-time systems and resource-constrained environments. Yeah, so for example, when we are talking about such systems like TFL, Yeah, where they're using prediction for train arrival time or tracking all of the trains, tracking all of the routes, paths, etc. They're using low-level languages, yeah, that can manage larger systems within shorter periods of time and takes less memory. Now let's have a look at the table, how we can compare them. So we can see that what they have, we can compare them in terms of syntax, abstraction, performance, development time, memory management, portability, use case. Yeah, for your exam, you will most likely be asked some kinds of this question. Yes, so usually you are asked either to compare some high or low level languages or some devices or hardware. Yeah, so it's very easy when you are providing such a table, and in table you need to define differences. Yeah, the important thing that you need to show. Yes, so for example, you can see that here I'm writing human readable and a machine oriented. Yeah, so you can see that these are two different statements. Yeah, so in case if you write down in your table human readable for high level language and non-human readable for low level languages, it would be considered as one difference and one mark only. So make sure that the points you are making, they are different, yeah? Like in this current case. You can see that, again, we are saying in abstraction using high and low abstraction. This is, again, two different points. Performance, when you explain in why it's slower due to overhead, and they're saying it's fast and optimized, these are two different ones. Yeah, obviously, if you say the one is slow and other one is faster, is going to be taken as one point and one statement and one mark. Faster, longer, as you can see, development time is going to be one statement. And you might ask me why it's taking longer for low language to develop and for high level languages it's faster. Yes, I mentioned before, there are lots of libraries, there are bigger communities, people do not care as much about memory management, etc. Yes, so it's a very common statement in development world that we can develop a project using high level languages faster using less resources, or we can take longer time and use more resources, but it depends the difficulty of the project. In case if we are talking about some kinds of site, we obviously would use high level language. In case if we are talking about some difficult server system in a school that stores all of the databases about students. Yes, so we would need something that is working really fast. Yeah, and as we mentioned before, memory management is manual in low language and automatic in high level. Portability, cross-platform for high level, system specific for low level. We are going to talk about use case in the next slide. So now let's have a look what we can use our languages for. So I'm going to show you 8 examples now what we can use the languages for. Again, in case if we are talking about system programming, yes, such as different drivers, different system software such as OS development, utilities, we would use some C-based language or assembly language. Yeah, that allows us to work with software directly. Yeah, so for example, those who play video games, especially PC gaming, they know that sometimes if you want to play illegal games, you need to wait for the moment when the game is cracked. And what is cracked game mean? Yeah, it means that there was some assemble code written to deassemble game application code that works directly with your software. Yeah, and we need to define why it's not secure to play cracked games. Yeah, because as it mentioned before, it's using assembly language, and assembly language allow developer to work directly with hardware. Yeah, so you don't know what it can do to your hardware, what resources of your CPU and your RAM it can use. Yeah, so for example, it's very common that in such software like Photoshop, etc., developers implement some code that is able to work with your web camera directly. Yeah, and I don't know if you ever used it. I use it just for experiment to see how it works on my device, and every time I run Photoshop, I can see that camera on my laptop becomes green. Yeah, so it means that someone is able to watch me through the camera, yeah, in such kinds of devices. Yes, sometimes you can notice that your laptop or PC is working way faster. You can see making much more noise, yeah, because again, it has direct access to your hardware. Yeah. Next thing, again, embedded systems. Yes, as we mentioned before, for transportation, trafficking, big database systems, it's better to use C++ language. For web development, yes, so it can be Python, JavaScript, Java, even Ruby, Ruby on Rails, etc. They are faster in terms of implementation, and they use high-level abstraction. Yeah, it's quite easy to develop projects using these languages. Yeah, for data science and AI, we are using Python and R. Obviously, you can use other languages such as MATLAB. Yeah, MATLAB is not really a language, but it still allows you to use some specific tools. You can also use Java. You can use Scala, you can use C++ to develop some libraries that you can embed in Python or R for data analysis, for example, or running some models, yeah, machine learning models to work with. For game development, so we were talking about game cracking before, now we are talking about game development. You must have heard about such software as Unity, and there was one more, Unreal Engine, yeah. So as far as I remember, Unity is using C# and Unreal Engine is using C++. Correct me if I'm wrong. I'm not a game developer, so I might make mistakes in this concept. Yeah, so these languages again allow you to develop from simple games till games like Witcher, Cyberpunk, yeah, GTA. Yeah, so for example, God of War. All these games were using C++ and C# to be developed. Yeah, for mobile development, you can use Java or Kotlin. Kotlin is a language developed by Google, yeah, to work with. Android development, Swift is Apple developed language. Yes, for iOS, there are also other languages. Dark, at the same time, you can use even JavaScript and Python, React, different languages that can allow you to develop, but these three are most common, yeah. There was Flat. This language was really popular a few years ago. Again, as we mentioned, real-time systems, assembler C. And for scripted automation, yes, so for example, you want to develop a script that would remind you every 24 hours to take your pills. Yeah, so you would use Python or any Bash language that would send you notification in console, terminal, etc. Yeah, so I'll show you an example what it could be. In end of 2020, when PS5 was just released, yeah, it was incredibly difficult to buy it. Yeah, so people were like fighting for it. It was showing up for 3 seconds on the site, then 1 minute later, the site is gone. You can't buy it anymore. So what I have done, I combined some Bash and Python code. It was parsing some sites like Game. It was parsing Amazon, Currys, obviously Sony's site. I don't remember what else. There were like few platforms, few sites that were selling PS5 back then. And a couple of weeks later, it was like 2 or 3 weeks later, it started working pretty good, and it was in alarm sounds on my laptop as soon as it was able to find that console PS5 that it was on sale. Unfortunately, for example, in some cases it was like just 100 platforms and like 10,000 people were trying to buy it. Sometimes it was waking me up at 4 a.m. and I was not able to buy it. Yeah, but in the end, after 3 times it woke me up, I managed to buy it just using this simple approach. Basically, what we covered for now in this presentation, this theoretical part. So we have talked about high-level languages, what they're used for, and that they can be fast development using abstraction. Low-level languages, they offer high performance and direct access to hardware control. Choosing the right language depends on our needs and how many resources, including financial, we have, how experienced developers are in our team. What we are going to cover in lecture next part, we are going to talk finally about searching algorithm. Yes, so it's going to be linear search, binary search, and we are going to compare linear and binary search. So, thank you for attention. It was the end of our lectural part for today. So, first of all, we need to figure out what do we call a vowel. Let's start with enter a string. Let's call it S, and let's call it again S as well. Yeah. Total. So, what is a vowel in our current case? We know that there are how many? A, E, I, O, U, 5 vowels on them. Am I right? So knowing that there are only 5 vowels, what we can do? We can iterate through each of the elements in our input string. Yes, so there are 2 ways how we can do it. There is a Pythonic way how you can do it. You can iterate through each element in your string and compare it to one. Yeah. Another way is low-level languages approach when you're iterating through what? Indexing. Yeah. So we are going to work with the second way since it's required for your exam. So let's have a look. What would we? I will provide very simple example for you how you can do it. So let's do what? Let's go for index from I starting from 0. Yeah, we remember that it starts from 0 to the length of our S. What would we do? We would need to have a look at the current character. Yeah, let's call it this way. And how would we access it? We would say it would be index of I. Yeah, where we know that value of I, it can be any value starting from 0 to length of S not included. Then we are going to compare if S I is what? Equal to, let's say, A. And now important thing, we need to say or here, yeah, because or yeah, so it should not be S I equal to A or A not capital. Yeah, it must be a legal comparison of a character. Yeah, so let's say we are comparing current character with some specific value. Yeah, I'm obviously going to skip it, or current char is equal to what? Like any other values. Yeah, I'm just going to keep just other values in this. So we understand we can add more cases later. Then we would obviously need to do what? We would need to and if. But in case if this condition is true, what we are going to do? We are going to increase the amount of total values by what? By 1. Total vowels, sorry, not values. Yeah. So and total vowels used in the word is going to be total vowels. Yes, 2015. Big. Yeah, perfect. Yeah, so this is again the approach. How would we find how we would count vowels in a string? Yes, so what would we do again? We would output some message in the beginning to enter some string. Then we would create a variable s where we would be storing user input. Yes, so we remember what we need to do. We need to use this horizontal arrow to specify that we are going to store the value there. Then we are going to use variable to store total vowels, total amount of vowels that are used. And then the next thing that we are going to do is what we are going to iterate from value of 0 to length of s, and we are going to in variable current char store the value of current value for index I. Yeah, again, that is starting from 0 and goes to len s, increasing by 1. Yeah, and let me show you. Yeah, and then we are comparing all of them. Yeah, we are comparing not just to A or E, etc. We are comparing current char to A, or current char to a non-capital, or current char to E, etc., etc., etc. Now, another important thing that we need to have a look at. As I said, in different languages, it works differently. So, what we are going to start with, in case if we are talking specifically about Python, we need to specify that it should be going until to length -1. Yeah, because it's pseudocode, so it's not 100% clear what your language referencing to. Yeah, so again, you need to be careful about what you're doing and what you're describing. Now, in case if we are working with some other language, such as let's say C++, C#, Java, etc. You would write down the next construction. For I equal to 0, you would say while I is less than at, and you are going to rewrite the value of I by 1. Yeah, this kind of code is legal in pseudocode as well, but again, I would recommend you to use just the first one. Okay, so let's move to the next problem about reversing the string. The next one would be about lists. Yeah, and next one would be about lists, and then I would show you how to work with searches in the next lesson, yeah, which would make more sense. So next task would be about how to reverse a string. Again, very simple problem that can easily come up. Reverse a string. And let's see what would we do to reverse a string. Yeah, so obviously the first thing, let's copy the entire thing again. Yeah, so we would enter the string, then we would say let's have some text, and we would need some variable reversed text. Yeah, so here we would store it just empty quotational marks. And what do we know? How we can reverse the string? To reverse the string, we basically need to move all of the elements from the end to the beginning. Yeah, so now what we are going to say, we are going to use Pythonic way again to do it. So we are going to say we are going to move from I to length of our variable text, and we are going -1, of course, and we are going to use from -1 to 0 with step -1. Yeah, and we remember that it's totally allowed in any Pythonic, in Python or any other language. And we can add text, right? Yeah, so again, what's happening here? We are moving from the last element. We remember that it's starting at 0. And we are moving to index 0 with step -1. So step -1 says that we are moving direction from end to the beginning. Yeah, now let's add look. Let's add formatting. And let's solve one more problem quickly about finding maximum value in a list. Find maximum value in a list. This one again, it's very popular problem. Maximum value in a list. So again, depending on the language that we are working with, there are different requirements. Basically, we need to define the length of the list that we need to enter in case if we are talking about low-level languages. In case if we are talking about high-level languages, we just can enter whatever and then we'll figure it out. But for good practice, we are going to define the size of the list in the beginning. Yes, so let's say enter list size, and let's go to store it in simple variable n. And then let's create empty, let's say we are going to have numbers list. So we are going to store it here. Then what would we need? We would need n-1 times to enter new value to add it to list. Yes, so let's say we are going to say numbers list. We are going to store the user input. Yeah, again, starting from what? From 0, because indexing in all programming languages starts from 0. And we are going to move until n-1 value. Yeah, so at this step, we were filling the list with some values. The next step, we need to define some variable. Let's call it max value. And we don't know what exactly is going to be equal to, but we are assuming that the first element in our numbers list is going to be the largest. So what we are doing next, we are going to move again from the first element. Actually, we don't even need to move from the first, we can actually already move from the second. And we are going just to run some simple comparison. What comparison? If numbers list current element is larger than max value, then we are going to do what? Then we are going to change the value of max value variable. And we are going to update numbers list I, and this is going to be largest value in the list is going to be max value. And now let's quickly update the formatting. Yeah, all good. Yeah, so this is the way how you can find the largest value in the list. Obviously, you can practice and develop your way of finding the list, the smallest value in the list. So this was pretty much it for today. Let me know, please, if you have any questions left. If so, I would be more than happy to answer.